Okay, so today we're talking about finding least common multiple of monomials. You had to do this on a Keystone Review day, and most of you found a factor instead of a multiple. And then we're also going to talk about finding greatest common factors. Number 2 is the one we're going to be using a lot. Tomorrow's lesson will deal with actually using this. So today we'll do number 1, and then we probably won't see it again, but number 2 we will use over and over again. Okay, when you find the least common multiple, first of all, let's make sure everyone's clear on what a multiple is. Multiples are basically what you get when you multiply. They're like the counting numbers. So back when you were learning your times tables, you might have practiced counting by threes. Those are all multiples of 3, what you get when you multiply 3 times 1 and 3 times 2 and 3 times 3. Those are the multiples. So multiples of a number are always either the same as the number, like the first multiple of 3 is 3, or they're going to be bigger than the number itself. Some numbers are easy to find common multiples of. So if you look at the numbers 3 and 5, if we go to the next multiple of 3, what would it be? 15. So the next multiple of 3 would be 15. It's a little smaller. And so we can see that 15 would be the least common multiple. That's the first one they have in common. There's a trick to find least common multiples for bigger numbers. I'm going to show you the trick. You're not going to need to use it a whole lot. I'm not necessarily going to expect you to memorize the trick, but it will help you understand why it works the way it does whenever we're using variables. So if we wanted to find the least common multiple of 18 and 24, counting by 18s and counting by 24s is a little tedious because they're big numbers. So what we can do is we can express each number as a product of prime factors. That's what you did in elementary school, where you took the number and you broke it down into its factors. So 18 would have been 2 and 9. 9 could have been broken down further into 3 times 3. Remember doing those? I used to like doing those in elementary school. I thought they were fun. So that's the product of prime factors. You break it down until you can't break it down anymore. So 18 looks like this. 24 looks like this. When you're finding the least common multiple, you have to use all the factors of the number. So you're going to use 2 as the first factor, and you're going to look at which number has the most 2's. 24 has the most 2's, so we're going to use 2 3 times as a multiple. We're going to do 2 times 2 times 2. And then they both have a factor of 3, but for number 18, we have 2 of them. So we're going to use the one that has the most occurrences, so we're going to use 2 3's in our number. Now when we multiply all these numbers together, we get the least common multiple. So 2 times 2 is 4, times 2 is 8, times 3 is 24, times 3 is 72. So the least common multiple of those two numbers is 72. Okay, now, our example, we're finding the least common multiple of 15 and 20. Stephanie, how would I express 15 as a product of prime factors? 5 and 3. 3 and 5 are both prime numbers, so 3 times 5 or 5 times 3. How about the number 20, Noah? 10 and 2, but then we could break the 10 down further. So we have 10 and 2. What does 10 break down into? 2 and 5. So we have 2 times 5 times 2. So 2 times, I'm actually going to write both 2's, times 5. We have 3 factors. We've got 2's, 3's, and 5's. We have 2 2's in the 20s. We're going to use both of those. 2 times 2. We have 1 3 in the number 15, so we're going to use 1 3. And we have a 5 both in the list for 15 and in the list for 20. Neither list has more 5's than the other, so we're only going to use 1 5 since one is in common. So we have 2 times 2 is 4, times 3 is 12, times 5 is 60. So the least common multiple is 60. So that's kind of a neat trick if you have really big numbers. Now with variables, if we're finding the least common multiple of 2x squared and 6x to the 4th, if we express 2x squared as a product of prime factors, we have 2 times, what does x squared mean? What do we do?
2 times 2.
2 times 2 times 2.
No, what does x squared mean? Just the x squared. It's not 1 times 1.
It's the variable 1 squared.
It's not 1. It's x
Over
squared
two.
means
X.
what times what? X times x. There you go. 2 times x times x. And then 6x to the 4th. Emily, what would that be as product of prime factors?
So it will be 6.
Not 6, because you can break 6 down. 2 times 3.
And then it would be times, well, x is 4 times.
Uh-huh.
Yeah.
Times 4x's. So we have 3 different prime factors. We've got 2, 3, and x. 2 appears in both only 1 time. So we're going to write down 1 instance of 2. 3 appears only 1 time. So we write down 1 instance of 3. And x appears, whoops, God, I changed colors. X appears twice here and 4 times here. We're going to use the 4 because that's the most times. So times x times x
Bless you.
times x. What does this work out to be when we multiply it through? Anthony? 2 times 3 is?
6.
6. And x times x times x times x could be expressed as?
X to the 4.
X to the 4th.
Thank you, Anthony.
Hi,
6x to the 4th. We had an echo of Anthony. Okay, so we don't have to go through this process every single time we do it. The shortcut is, if we look at the least common multiple of the constants, we can just write that down. So you can see, looking at 2 and 6, if we count by 2s, we have 2, 4, 6. If we count by 6s, we have 6, 12. 6 is the least common multiple, so we can just write down that 6. And then when we're looking at our variables, we just look at which variable occurs the most often. So they both have an x. It occurs more times in this one, so we write down x to that exponent. This will make more sense after we do a few more examples. So a squared and a to the 6th. We have a as a factor. No, we're not multiplying them here. We're just finding the least common multiple. So we're just going to pick the biggest exponent, which is 6. We're not doing anything with the exponents. We're just picking which one has the biggest exponent. So over here, we have an x, a y, and a z. So we have to account for all the factors in both numbers. X only appears once in each one, so we're just going to leave it as x. Y has a 5 here and a 1 here. 5 is bigger than 1, so we're going to use the 5. And z only appears once, so that one is x,
Z.
y to the 5th, z. Okay, next one, I'm going to use the cards. Hope.
Oh.
What's the least common multiple of 8 and 4, first of all?
I don't know numbers.
If we were to count by 8s and count by 4s, what number will we get to that's the same? 8. So we have 8. How many variables do we have? What are our variables?
Like 2.
What are they?
X and Y.
X and y, so we have to have both x and y. What's the biggest exponent on x?
2.
And what's the biggest exponent on y?
1.
1, so we leave it like that. Emily, next one. What's the least common multiple of 3 and 2? Good. And what variables do we have?
X to the 3 and 1.
Good. X to the 3rd, y to the 2nd. We have x and y in both. And the biggest exponent on the x is 3. The biggest exponent on the y is 2. Number 5, Claudia, what's the least common multiple of 5? And what coefficient is right here? 1. So the least common multiple of 5 and 1 is 5. And what all variables do we have?
X, Y,
Good. X, y, and z. What exponent would I write for the x?
4.
4. What exponent would I write for the y?
3.
And what exponent would I write for the z?
5.
No, I'm not adding anything together. Which one is biggest? Good. 3. Okay, questions so far?
No.
Okay. Let's talk about factors. Actually, let's not talk about factors. Wait a second. I need to give you the worksheet. What I want you to do at this point, I have a worksheet. We're going to do the first 2 examples together. Then I'm gonna give you 2 minutes to do as many as you have time for.
Oh.
Most people are able to do the whole worksheet in 2 minutes. So let me pause this for a second.
Oh, we're doing this.
Okay, so on your worksheet, you should have the least common multiple worksheet. The first one is xy and x squared. What is the least common multiple, Noah? What variables do I have? I'll have x to the second, and then y. So there's no y in this one, but when we're finding multiples, we have to use all the variables, whether they share them or not. Okay, number 2, we have x, y, z, and x, z. What's the least common multiple of those, Stephanie? X, y, z. Good. Okay, take 2 minutes and do as many as you can on the rest of the sheet, and then we'll talk about them briefly. Okay, third one. Reagan.
A to the fifth.
Good. A to the 5th. Kiara, the next one.
LMN.
Good. LMN. Cameron, next one.
PQ to the 5th.
Not PQ to the 5th. What would be the exponent on the P? P is going to be to the 5th because the highest exponent is 5th. But the highest exponent on Q is not the 5th. What is it?
P5 Q to the 3rd.
Good. P to the 5th, Q to the 3rd. Next one, Anthony.
A, B to the 3rd, C to the 3rd.
Good. A, B to the 3rd, C to the 3rd. Kyle, next one. No, Kyle's not here. Rebecca, next one. Good. X, Y to the 9th. Jackie's not here. Hello, Jackie. That would have been you. Carly, next one.
What if you see to the fifth?
Well, when we have the CD in parentheses raised to the 5th power, that means that both the C and the D are raised to the 5th power. Good. C to the 5th, D to the 5th. Haley, next one. Good. A to the 3rd, B to the 3rd. And Hope, last one.
A, B, C, D, E.
Good. A, B, C, D, E. Okay, we all good with multiples? Give me a thumbs up if you're good with multiples. I think
No.
everyone is. Okay, we're going to talk about factors now. The factors of a number are the numbers you multiplied to get that number. So when you're finding factors, it's actually more like doing division. Factors are always going to either be the same as the number or they're going to be smaller than the number. So when we wrote numbers as a product of prime factors, those were the numbers that multiplied together to make the number. So when we're finding the greatest common factor, we're finding what's the biggest number that can divide into both of the numbers that are here. So for 4 and 6, Emily, what's the greatest common factor? 2.
Nice.
Number 2, 15 and 5. Claudia, what's the greatest common factor? No, it's always going to be the same as or smaller. It has to be the smaller than the smallest number. Because 15 is not a factor of 5. 15 doesn't go into 5. Think about what the factors of each number are. 5 only has 2 factors, 5 and 1. What factors does 15 have? 15 has 3 and 5. Which factor is in common between the two of them? Which one do they both have? 5. So the greatest common factor is 5. 5 goes into 5 once, it goes into 15 3 times. Noah, greatest common factor of 25 and 40? 5. It's also 5. 5 goes into 25 5 times and into 40 8 times. Now when we're finding the greatest common factor of monomials, we first find the greatest common factor of the numbers. So the greatest common factor of 2 and 8 is 2. And then we have to pick all the variables that they both share. They have to have them in common, and we're going to use the smallest exponent when we're doing greatest common factors. So on this one, they both have an A. The smallest occurrence is an exponent of 1, so we just write 2A. They both have a B. The smallest is 2 to the first power, so the greatest common factor is 2AB. On the next one, Stephanie, what's the greatest common factor of 16 and 12? 4. And then do they both have an S? Okay, so we write s to what exponent? Second. Do they both have a t? Okay, and what exponent will we use? Good. Megan, try this one. We have 3 monomials, so they have to all have the same factors in order for us to write it down as a factor.
Okay.
Just y?
And
Anything else?
that's
That's it.
Yeah.
That's it. So the only common factor in this, they all have a y. The smallest exponent is 1, so that one just works out to be y. Okay, we have a couple that we're going to try together. We'll go over these together, and then we have some that we're going to do on the worksheet as well. Kiara, what's the greatest common factor of this set of monomials? 3. Look at what variables they share. C. That's it, and the smallest is all exponent of 1. Cameron, what's the greatest common factor?
2.
2.
A to the second. B to the third.
No, we want the smallest exponent. So here we have b squared, and here we have a b to the 3rd. We want to pick the smallest one.
2.
Okay, good. And the last one, Anthony. 3 to consider here.
5.
Good.
S to the second.
Good.
T to the nothing.
To the 1, it's not to the nothing. If it were to 0, it wouldn't be there.
And U to the 1.
Good, very good. Okay, any questions about this? Okay, we're gonna head to the computer lab, practice this on Study Island. It really will only take 5 to 10 minutes for you to get proficient at this topic.